So in this video we're going to discuss about virtual functions in C++. So before writing the actual definition of virtual functions, first we will discuss some examples of when to use the virtual functions and where can we use the virtual functions. So the first question that I will answer with the help of an example is why we need virtual functions. So what is the need of the virtual functions? So basically a virtual function is just a member function and it is declared within the base class. So it has to do something with the inheritance and then it is redefined by the derived class. That means that virtual functions deal with overriding. So I'm going to write here in the brackets overriding. So in the C++ playlist we have already discussed function overriding in C++, and in that we already discussed an example where we can override the function declared in the base class and using the object of the derived class. So I will discuss that example too. So if we can actually do the overriding work, if we can actually do the function overriding without using virtual functions, then why do we need virtual functions? So let me give you an example of that. So first let me open the editor. So in the functions overriding video we have discussed an example. So let me just write the example first. So first things, we are going to create a base class. Inside this base class there is a public section and I am going to create a function in this public section. So let's suppose this function will display that it is inside the base class like this. So this is the base class and now I'm going to create a derived class and we are going to publicly derive, and now I'm going to create a public section again. So let me just focus here. So now in the public section I will again create a function with the same name as that of in the base class. You can see here this is the void function, and here also I will create the same void function, and here I will derive it. I will write inside derived class. Alright, so now you can see that we have created a base class and a derived class, and both of them have the same function. So if I will create an object of the derived class, let's say D, and if I will call the function which is the fun function using the object of the derived class, it will call this function which is inside the derived class, and thus it is overriding the function of the base class. This is what we have already studied in function overriding tutorial. But if we can actually do the overriding work, why do we need virtual functions? So first of all, let me just run this program and then I will show you the output. So first I will compile it. So now you can see here that it is actually saying inside the derived class. So it has called the function of the derived class. So this type of function overriding is known as implicit function overriding, and implicit function overriding is sometimes also called as function shadowing, because the function of the base class has been shadowed by the function of the derived class. So if this is a condition, if you want to use the virtual functions, why do we need them? So the answer is that, let's suppose I will create a reference or a pointer to the base class. I will create a reference base pointer, let's say it's bptr, base pointer. Okay, so now I have created a pointer that is actually pointing to the base class. So now what I'm going to do here is I will create an object of the derived class. I will create an object of the derived class. In the next line, I will write the pointer of the base class. I will assign it to the reference of the derived class object. So in this line, in this one, b pointer equals to ampersand d, I have created the object of the derived class. And whenever we know that whenever we create an object of the derived class, it will have some functions in it and some member variables which are allocated in the memory. So it will have some address. So we are taking that address using the ampersand symbol, and then we are assigning that reference to the pointer or the reference of the base class. So if I want to call the function, and now I will use I'm not going to use the derived class object, rather I will be using the pointer. So if I will use the pointer function, let's see which function will be called. So you can see that the base pointer btr is assigned a reference to the derived class object. So if I will use the pointer of the base class and I will try to call the function, let's see which function will be called. So first I will just compile it. So you can see that it is displaying inside the base class. So you can see that in this line, in this one, the programmer wants to do overriding. So you can see here that this line is actually written by the programmer because the programmer wanted to assign the reference of the derived class object to this base pointer, and he's doing that because he wants to call the functions of the derived class. But whenever he will try to use the pointer bptr, which is the base pointer, and he will try to call the function of the base class is not overridden by the compiler. But in the previous case, we have seen that if we will just use the derived class object, it will override it. So now we will have to do something so that the compiler will actually override the function of the base class. You can see the output here. It is calling the function inside the base class. So we will have to do something so that the compiler will actually override this function, and it does not depend which pointer you are using. So what I will just do here is, in order to do that, I will just declare this function as virtual function by using this keyword virtual. So whenever you declare a virtual keyword or a virtual function inside a base class, it does not matter which pointer you are using, which reference you are using. Whenever you will call the function using any reference, you can see that the reference is of base pointer. But if you will use any reference, it does not matter. It will override this function, this virtual function, and it will implement or run this one, which is inside the derived class. So let's now see the output of this program and see how it changes. So now you can see it is saying inside the derived class. So this is the main use of virtual functions. So virtual functions are basically safe, because if you will use the virtual keyword, then you can actually you are actually telling the compiler explicitly to override the function of the base class. It does not matter which reference you're using, it does not matter the reference. So when the reference does not matter and you want to do the function overriding work, this virtual keyword is used. And in most cases you can also use the override keyword here, which actually tells the compiler that the function to be you will have to override should lie here. So this is a program that actually shows how the virtual functions work. You can see that a pointer to the base class, when it is referenced to the derived class, it will automatically override it, and it will override this function only when it is virtual. If it will not be virtual, it will not override it. So virtual functions are just a way to actually do the overriding work explicitly. So now what I'm going to do here, I'm going to actually define what exactly is a virtual function. Alright, so let's define what are virtual functions here. So virtual function, when you refer whenever you will refer to a derived class object, as you have seen in the program that we have created a derived class object and we are referring it using a pointer, or a reference to a base class, or a reference to a base class. So I think this line must be clear to you that whenever you are referring to a derived class object, that means we are using the ampersand d, and you are using a pointer or a reference to a base class. You can see that we have already used the pointer base pointer btr b pointer. So this line means that whenever you are referring to a derived class object using pointer or a reference to a base class, you can call a virtual function for that object. You can call a virtual function. In our case it was fun. So you can call a virtual function for that object, and execute the derived class version of the function. Derived class version of the function. So if I would have given this definition at the very first of starting this tutorial, it will make no sense to you. So now we have done the whole implementation here. You can see we have done the whole implementation. So this whole definition makes sense here. So you can see when you refer to a derived class object using pointer to a base class, so you can see that we are referring it here. So let me create a derived class object D. So bptr is equals to reference of D. So whenever you are referring to a derived class object, you can call the virtual function for that object, which is D, and execute the derived class version of the function. That means it is actually saying that we are doing overriding. And what we are overriding? We are overriding the function fun of base class. So you can see that by providing the virtual keyword here, we can actually explicitly tell the compiler to override the function fun, or else it will not override in this particular case. So it's safe to write the virtual in front of a function, because in any case it will override it. It does not matter which pointer you are using. So now there are some important points about virtual functions that I'm going to write here, which are also the rules of the virtual functions. So I'm going to write here rules of the virtual functions. So when can you use a virtual function and what are the rules of the virtual function? So first rule is that virtual functions cannot be static. Virtual functions cannot be static, and they can and also cannot be a friend function, and also cannot be a friend function of another class. So we have not discussed friend functions at this point. We will discuss it in the next tutorial. But remember this point that the virtual functions cannot be static and they cannot be the friend function. So virtual functions should be accessed using the pointer or reference of the base class type. So the second rule is, I'm going to write the second rule here, that virtual functions, I will represent it by VF, should be accessed using pointer of base class type. To achieve runtime polymorphism. So polymorphism basically means that you have a same function with the same name, but they're doing some different things, and runtime polymorphism means that you are actually implementing the polymorphism at runtime when your program is running. So the virtual functions should be accessed using pointer of the base class type. So it is mandatory that you will access the virtual function using the pointer of the base class type, as we have done in the example also using this line. So this was our second rule, and the third rule is that they are always defined in the base class. And they are overridden in the derived class. So this means that you will have to write the virtual functions inside the base class, and they are overridden in the derived class. And we know that we can also write override. We will write override keyword so that it will just override the function in the derived class, so that the compiler will know which function to actually override. And in this way we can also redefine the virtual function by overriding it. So in that case, the base class version of the function will be used. So now we have discussed about virtual functions. In the next tutorial we are going to discuss about the friend functions, and we have also discussed a very good example here. You can see we have discussed this example. I will give this whole program inside our Android application so that you can see this whole program there, and you can run it yourself in your CLine IDE or any other IDE that you're using to actually learn how this whole working is done. So I hope you like the video. Make sure to subscribe our channel and make sure to share this video with your friends, and thanks for watching.